Hi, everybody. It's Deborah Carter here with Preparation Tech. Today, I have an amazing interview with a very interesting person named Jen Selby. And Jen is a machine learning engineer who works for a company in Silicon Valley called Blue River Technologies. Jen is really special too because on Thursday, March the 11th, in the evening, Preparation Tech is actually organizing and facilitating a session during the Mozilla Foundation's Moz Fest 2021, which is an online virtual festival with all kinds of sessions for adults and for kids, young kids, high school students. We will be moderating an online panel for high school students, which will teach them about AI, what it is, why they should care, and then give some specific examples. And Jen is one of the experts who's going to talk about how her company is using AI. So Jen, welcome very much. We're happy to have you here. Let's just start with you telling us what you do and how it relates to technology.
Sure. As you said, I'm a machine learning engineer at Blue River, and Blue River is working on using artificial intelligence and computer vision to change how agriculture is done, to make it more sustainable, to make it easier, to make it more productive, using this technology that has been developed in lots of other areas in the past. In particular, right now, we have one product called See and Spray, and what it does is attempt to recognize where the weeds are in a field. And so rather than spraying herbicides over the entire field as it's done now, it would pinpoint, oh, here's a weed, here's a weed. I'm going to spray just here with these little precision nozzles that it has. And so you can drastically reduce the herbicide use, perhaps up to 90%, making it more environmentally sustainable, cheaper and easier for farmers, and so just allowing you to get the same amount of crops for far less resources.
Wow. I mean, this is game changing when it comes to agriculture and farming, right? Because all of a
We think so,
sudden,
yes.
yeah, all the pesticides, the herbicides, the fertilizers that are overused now, this makes it very efficient. This is very cool. Tell us a bit, just on a very light level, about the technology that allows your machinery, your equipment, your technology to be so precise.
Right. So it's a combination of the robotics and the computer vision. So the computer vision is the brains. That's the part I work on, where it's how do you teach a computer to learn to recognize things like, this is a corn plant, this is a pigweed, right? Or whatever particular combination you're going to have in any particular field, so that it can figure out where it should be spraying. But then you also have the robotics, because you need something that can actually take that information and say, oh, if you want me to spray here, okay, I'm going to go do that, right? So you need both of them working in concert together to be able to make this machinery work. And it also is a little bit different too, because a lot of the other computer vision projects where they're learning to recognize things, or having computers learn different things that humans can understand, is done in huge computers in big racks with lots of power. But we're trying to make it run on tractors or sprayers or different farm equipment, so the resources there are very different as well. So we've had to figure out, like, how do we adapt these things that other people have developed for these other applications, so that they work in farm machinery, which maybe does not have any access to the internet, doesn't have a whole lot of extra electronics that we can put on. How do we make sure that our system is efficient enough that it will work on farm equipment?
So it's kind of like a detective, like you are solving this problem and you're gonna have to re-engineer a lot of stuff, right? So what does a machine learning engineer typically do, right? Because it sounds great, but what is it that you actually do? And then how do you work on a typical project? Explain, give us an example of a typical project you work on.
Right. I definitely want to start out by saying it varies a lot from company to company what that job title means. But I think in general, what you're trying to do is figure out if, if somebody has these different ideas for how they want to make a computer learn something, how do you help them do that, right? And so it might mean that you're helping them with gathering the data set. So one thing we had to do is figure out, okay, we need to give the computer a whole bunch of examples of, the images it might be looking at and saying, here's a weed, here's a weed, here's a weed, so that it can build up that information about, oh, this is what weeds look like. This is how I could learn to identify it. So a whole lot of time is spent saying, what data do we still not have that we need? What areas do it, like, maybe we don't have enough where we've seen, what does a weed look like when it's cloudy? What does it look like when it's raining? So there's all these different situations. And so a lot of time is spent making sure that we have not only the data there, but available in a way that people can actually find it when they need to um, have examples of certain things, that they can easily find that. So we spend a lot of time making sure the data are available and not biased, and not missing pieces that would mean that the system isn't going to learn things that it needs to learn. Um, Other pieces of it, like I said, is making it faster, smaller, or run more efficiently. And then another piece of it is often thinking about, if you're doing all of these experiments to say, oh, I had this idea, maybe this will help the computer learn better. Well, you kind of want it like a lab notebook. So if you could have it automatically remember, well, you tried this, 3 months ago, and this was the result, and you can go back and say, oh, but I had this other idea just a little bit different. Let me take that experiment back off the shelf and reuse it. So we're often working on systems to make all of that as fast as possible, so you can run as many experiments as possible, try out different things, and really have a sense of what works and what doesn't. You read a paper about somebody who tried some new thing that you think might work for you. You want to be able to quickly run those experiments and figure out, did this actually work? Or, is it something we want to try something else instead? So it's a lot of those, all of those different pieces of the system where we're trying to help our data scientists be able to do the experiments, and also come up with some ourselves, where I noticed that we're having this problem over here. What if we tried whatever?
Interesting, interesting. So I'm talking to you, and you obviously know a lot about this stuff. Tell us, what kind of college or university degree do you need to become a machine learning engineer? Do you need a degree?
You don't necessarily need a degree. It's definitely a field, I think, that is more based on knowledge, but typically you would have a degree either in computer science or statistics or math, um, if you were kind of focusing on machine learning. But other times you might have a degree in the specific area that you would be using the machine learning. So maybe you have a degree in public health, where you've gotten to learn a bunch of the statistical methods that you would need to know, or in we have plenty of people who got their degree in agronomy, which is a study of agriculture and plants, and then they've learned these specific math and statistical and computer science ideas that they needed in order to apply those to their field of expertise. And we absolutely couldn't work without that, because I definitely do not know enough about plants to be able to do what I'm doing without having experts in that field. So I say you can come to machine learning from any different direction. It's just a matter of building up the skills that you need on top of whatever particular degree you had. And even a typical computer science degree won't necessarily go over some of these areas. You have to decide if this is what you want to get into. You need to learn linear algebra and statistics, and then start learning some of the different tools that are used in the machine learning and artificial intelligence fields.
Wow. Okay, so you've covered both the degree programs and also some of the subjects. We're going to come back to that because I'm going to talk to you about your
Sure.
personal education. So my next question is, what are some of the advantages of the tech? You talked about it a bit, but let's go over it again. The advantages of this smart farming robots that you're helping to develop.
Sure. So definitely one of our big missions as a company is to make farming more sustainable. Um, we are a subsidiary of John Deere, and so we are working to help their equipment be smarter, to learn ways that it can do even better the jobs that it's doing, so that we can decrease the amount of resources needed, um, decrease, runoff. Uh, that could also have a secondary effect of carbon emissions because everything that you create is going to use energy, right? So all of these things could help decrease the amount of resources we need to produce the same amount of food, or possibly even increase the productivity of food so we can feed even more people with
Right.
the same amount of land.
Right.
So it's figuring out how various different technologies have been developed can be applied to agriculture to make these farm tools um, smarter, better targeted, and using less resources.
Oh, awesome. Awesome. So I see before me someone who is super, super enthusiastic about what she does. Take us back to your childhood, Jen. What kind of a child were you? What were your hobbies and interests? What were you good at school? Who were your role models?
Sure. So I was definitely a nerdy child for sure. I really loved reading, and I just spent a lot of time in the library, and we would go to science museums, and I definitely liked a lot of that. But I was also a bit of a jock. I played a lot of sports, uh, softball, soccer, basketball, track, ice hockey. You name it, I probably tried it. Yeah, actually still play ice hockey. Um, yes. So I was definitely a mixture of kind of different stereotypes, I guess. Um, I loved art and drawing, and I played the piano. So I had, I like to think I had a pretty well-rounded thing, even if maybe nerdy might have been the first thing that you would notice about my personality. Um, but yeah, I enjoyed school overall, and uh, I think most classes I could figure out something that I wanted to get out of it, even if it wasn't my favorite class.
Exactly. So you have quite an impressive educational background. Okay. You've got, I believe, an undergrad from UC Berkeley,
From MIT.
from MIT. Yes. Undergrad from MIT and master's.
So actually, the UC Berkeley is interesting. I was not ever a regular enrolled student there. I found out, and this is a really neat tip: if you live in California, um, you can attend any class at any University of California, Cal State, any of those. Um, if there's room in the class and the professor will agree that you can be there. So if you meet the prerequisites or at least close to it, you can go take the class. It's not cheap, but it's cheaper than a lot of other options. And so yeah, I found out about that, and I was in a job where I had never taken a statistics class before, but machine learning was just starting to be a thing. It hadn't didn't have that name yet, but we wanted to move into that, and there weren't really many people that knew how to do that. We weren't able to hire people, and so my boss came to me and said, "You like math, right? How would you feel about learning statistics and, and going into this field?" And I said, "Sure, why not?" And so I just started taking master's level stats classes, one at a time while working full time. My company would just let me disappear halfway through the day to take a class and come back. Um, and so I never enrolled as a regular student or got a degree or anything, but I took most of the classes that I actually think maybe all of the classes I would have needed to get a master's in statistics,
Oh
but I
my.
do not have one.
But this is amazing. I had no clue that this was a rule. So, folks, if you reside in California,
Yeah.
then you have the ability to take these courses. You have to pay for them, but the ability is there. That's fantastic.
I know. I was
Fascinating.
so excited when I found that out.
Wow. So then you worked as a software engineer at several companies before making the move into machine learning. Tell us a bit about your journey in the different companies.
Yeah, so I've done, yeah, I've worked in a lot of different areas, I guess. I started off doing more, working on really huge, like, I think at the time they would have been called supercomputers, um, doing very low level things of like, is the computer actually working? Make sure that nothing has caught fire, you know. Um, and then I moved to a company that we were doing automatic geography tagging. So, you have all of this information and it often mentions places. and the places are quite relevant, but how do you search for, I want everything in this county? Almost no documents may have mentioned that county. They mention specific places in the county, right? So thinking about, we often have information that's arranged spatially that you can't just do a simple text search to see where they are. So our software would actually go through and pick out, this is a place, and it's specifically this place at this location, and you could put it on a map and visualize it. And so when I started, I was just working on the general system, the database, and which would store all of the information about these geography places. And that's the company where they said, hey, we're moving to this more statistical model-based form. Can you can you learn statistics and help out the team that we have that we want to enlarge so we can continue working on these models.
Wow. And your
Um,
degree
yeah,
at MIT was in,
just computer science in general.
yeah,
Computer science
okay.
and engineering, I think, was
Right, right. So
the
not so much
official title.
statistics. Not so much
I
statistics.
had never taken a statistics class before doing this. I had to learn it all from scratch.
Oh my gosh. But you did it. You did it. You had the will and you did it. And it
It
helped
was so
that you,
interesting.
yeah, and it helped that you were already in that kind of frame of mind with the computer science and the
Right, right. And I had taken classes in probability, which is related, and I'd taken plenty of classes in other areas of math, just not statistics.
right, right. So you're a math whiz, okay? So you just admit it, you're a math whiz.
I definitely enjoyed math for sure.
Okay, okay. And you had an interesting kind of change in career because you were a high school teacher with computer science, and you were
Yeah.
one of the first to develop an AI curriculum for high school. Tell us about that, because this is directly related to our panel on
Right.
Thursday.
Right. Um, so what happened basically, I was working as an engineer, but I had always done a little bit of teaching. I was involved in a program in college where undergraduates got to teach freshman classes for freshmen who opted in for the program. I had done after school tutoring. I had helped out with a couple of events with like Black Girls Code. So I really enjoyed um, uh, teaching, at least on the side. And I decided, what, I'm thinking about switching jobs. Why don't I line it up with the summer, take the summer off, and teach at a summer camp? And so I did that. I taught for Girls Who Code, and it was a lot of fun. But I was still at midway through the summer thinking, okay, I need to start my job search for an engineering job, when a couple of my friends sent me emails saying, hey, we know somebody who's working at this school. It's a pre-K to 8 school, and they're expanding into adding a high school on, and they want to have computer science there. They need a computer science teacher. And so my initial thought was, well, I'm not a computer science teacher, but I guess I'll go hear what they're doing. And basically, because it was both a new high school and they were adding a computer science program throughout the entire school, they said essentially you get to decide what can a computer science education look like at all ages, right? You get to design all of the curriculum, figure out like what kind of we're doing, and so just the idea of thinking like, oh, I would get to think like, what motivates people? What kind of things are they interested in? How young can you learn computer science? Because I didn't see any of it until high school, and I never took a formal class until college. So what would it look like for a second grader to be learning computer science? And that was just such an interesting opportunity that I couldn't say no to that. So I started teaching, and let me tell you, even having done tutoring and other classes, I had so much to learn. So just like with the statistics job, is like, okay, I need to figure out like what am I missing? What do I need to know? I was lucky to have a ton of great mentor teachers, and a culture where they were like, sure, come sit in my classroom and see what I'm doing. So I would observe and take notes and go, oh, that's that thing they did there, that's what I should have done last week. And so I got to learn a lot about the teaching profession, but also a lot about how do lots of different people learn computer science, right? And it really helped me also thinking like, oh man, if I had done that as a student, I would have done much better, right? Because you just get to see how lots of different people handle learning new things and how they do that. Um, and so, yeah, you asked about the AI curriculum. There are definitely a couple of different schools that had it, but it was not something that was generally taught at high school level. But I had a couple of kids who'd read some things about, like, what Google was doing, and some of the new techniques that were coming out. They were really excited about it. And so we started talking about it. And the more I talked to them and saw all of the new tools that had been developed that made it much easier to do this without all of the high level math, because that was already written and available for free for people, I went, wow, we could do this. And so a colleague and I, and it was, we were a nice match. He was a statistician who'd learned computer science. I was a computer scientist who'd learned statistics. Yes. So he and I put together this course, and basically looked at different examples of college courses and said, okay, so how do we take the parts that are understandable to high schoolers and make sure that we're, giving as much background as we possibly can, and maybe also pointers to, like, once you learn some of this other things, then you can also learn this part. But explain all of these techniques that were currently being used, that were cutting edge research, at a level that our high schoolers could understand and engage with, and figure out the tools that they could use so they could actually be doing these projects themselves. So it was a ton of fun. And it's the most popular computer science elective that I developed at that school. Every single year we would get at least 30 kids sign up.
My next question. So you're obviously a female working in tech, in a very specialized area of tech. What have been some of the hardest challenges that you faced? And more importantly, how have you overcome them?
It can be hard at times. I would say overall, my experience has been quite positive. The vast majority of my coworkers are supportive. They, treat me with respect. I am, you know, a equal member of the team. But it is hard. I have been the one female engineer in the company at a number of times. Fortunately, not right now. I have some great female colleagues. Um, but I think the hardest thing is the sometimes having to think about, what is real here, right? So you're given a piece of feedback, and you're, like, how much do I incorporate that? What does that mean? And sometimes even, would that feedback work for me? I think if my male colleague did this, that would go well for them, but would it work for me? I'm not sure. I might be perceived differently if I did this than they would. And so you have this weird, like, not always being able to trust things that people are saying, or reactions that people are having to you, in a way that you might if you were seen as somebody who is obviously belongs here, obviously is good at this. And so just for example, you might have an idea that you think is really good, and it doesn't get much traction, and you're like, okay, is that because I need to go back to the drawing board? It's not that great of idea. I need to adjust it, or is it because I maybe need to bring in another colleague to second it, and have people look at it? And you know, it's, I think, even for people who are very well meaning, sometimes our brains fail us and do that. And I felt that even myself, where I've noticed, wait, I don't think I was treating my female colleague the same way I would have treated my male colleagues. I need to go back and fix that, right? I think all of us have these, you know, unfortunate biases built up in our heads, and I think you need to often be proactively trying to fix that, and understanding how these dynamics play out. And so it's really challenging, right? And figuring out, um, who are the colleagues that you can really trust, that will have your back, that you can go and talk to them, and also get that reality check. You saw that too, right? you know so I think it certainly can be tricky, when again, just when you're like the one person there, or a small number of people there. And so finding people that you trust, people that can help you navigate company politics and everything, that's super important. And you know the faster you find your people that you can work with closely, the better, for sure.
Yes, excellent advice. Have your tribe, have your community. And I hear this over and over, especially from the women, but also people of color, for example.
Oh, yes.
It's so important, and it's wonderful because online there are all these communities out there that you can join. So this is fantastic. I have one last question, and probably is one of the most important questions, and that is, how can we prepare high school students to enter into study programs and also careers related to tech? How can we get more girls interested, more kids of color, but to raise the amount of people that are interested in things like machine learning and AI?
Um, yeah, so I think the biggest thing is helping kids understand how to learn new things. Um, and, as I think I've talked about, I had to, on the job, learn lots of new techniques and things because things are constantly changing. And especially in a young field like machine learning, you're going to have new tools that come out or new papers, and you need to know how to incorporate new information and how to not be intimidated by saying, "Oh, well, I thought I wanted to do this project, but it involves this other tool that I don't know." No, like you want to be able to go and learn that. So I think helping students learn how to learn what motivates them. Sometimes kids will ask me, "What's the best way to learn this?" And I said, "The way that keeps you going." Right? Because anything, this might be the fastest way to learn it, but if you don't like it and you're not going to stick with it, it doesn't matter. Right? So finding things that where, are you a person that really needs a project? Are you a person that needs your friends to be working with you? Are you a person that needs to really talk through ideas? Do you need all of the above? Right? So what is it that motivates you, that gets you learning, that helps you figure out how do you break down problems? Really understanding yourself so that you can be a lifelong learner. I think that's the most important thing for anything, but especially in a field like technology, which is often moving and changing, um, and requiring that you um, update your skills and learn new techniques and figure out, like, what are the best practices now, that they are going to be different from maybe even a few years ago. Um,
Absolutely.
so in terms of getting more girls and underrepresented minorities into computer science, um, it's definitely a hard problem. And one thing I've had to realize is, as someone who was so compelled by computer science that I got into it when very few people who look like me were in there, what worked for me is not necessarily going to work for everyone else, right? Because you know, I each person is going to have a different path there. So um, I think not overgeneralizing to your own experiences, but really looking at, like, what have different people tried, what research is out there. So, for instance, I would recommend Professor Colleen Lewis at Harvey Mudd University has done a lot of research about computer science education. So definitely check out her. So they have a whole page of different tips and everything. Um, but I think a couple things that have worked at least somewhat for me, reaching out to specific students. I've often been surprised. I mean, even with the students who do look like what people have in their mind as a computer science person, there's often a lot of doubt, right? And so sometimes just saying, "Hey, I think you might be interested in this," and with kind of the underlying implication of "you're definitely capable of doing this," can really change things for students. So I think trying to talk to each student individually and say, here's something that you might be interested in, and just giving them a sense of, like, I believe in you, you can do this. It's hard, and you can do it. I think can help. And the other big thing, and this is something I definitely learned uh, by practice, is the culture of your classrooms is so important. Um, Really making sure that everybody feels comfortable, that you are helping the kids that are really excited, also give space to the kids who are just coming in and learning. Making sure that your class is not only for the kids who this is their life and what they breathe, because all of the students will have something to contribute, and people coming in as beginners often can see it in a very different way and really add to the classroom, but only if they feel comfortable in contributing. And that's something you really have to work on as a teacher, far more than I would have guessed when I first started, is making sure that you have that comfortable space where everybody can feel like they belong. And then the final thing is just trying to have it be more of a social thing. So trying to get one uh, girl or underrepresented minority probably isn't going to work, but if you can get the whole group of friends, that helps a lot because for a lot of people, like this is a cool thing that you can work on together, right? You can be all contributing to a project and talking about the ideas, and it's much more compelling that way, I think, for students if you can um, get a whole group involved as opposed to any one person.
Absolutely. What you're saying really resonates with me, because I run a tech education academy. And yes, we want groups of girls. We don't want just the one. And also, the power of, so I'm not a teacher myself, but I work with a group of teachers. And so I often go to the classes because I'm the cheerleader and I'm cheering every kid, but I'm really focusing on the girls. And we had one computer science class, and this was for a group of kids that are like 10, 11 years old. And, obviously there's boys that have done this before, but there's a lot of new girls. And they're like, we think we like this, but we need more on the programming side of things. And to be able to really to keep the boys motivated, so we give them really hard challenges. There's some girls in that group as well, but
Right.
then we really slow it down, and we took a few classes to do that. And now those girls that felt they were behind are catching up really fast. So you're right, you have to kind of gauge it and not only play to the people that are really into it already, because the discovery process is beautiful, beautiful. But Jen, we are at the end of the interview. It was fantastic. I feel like I've learned so much, and I cannot wait to be on this Mozilla Festival panel with you. Thank you so much for sharing your insights. And again, folks, a Thursday, March 11th, from 7:15 to 8:30 CET, from 1:15 to 2:30 Eastern Standard Time, and from 10:15 to 11:30 Pacific Standard Time. Anyone is allowed to participate. So if you know any high school students or high school teachers, please invite them. It's free and it's going to be super interesting. Jen, thank you, and I wish you all the best.
Thank you so much for having me and for all of the work you're doing.
Thank you.